All right, today we're going to look at section 10.5, looking at parabolas. For starters, go ahead and fill in this table for the two equations y equals x squared and x equals y squared. All right, so when you fill in the first one, y equals x squared, when you plug in x values, we should get 16, 1, 0, 1 and 16. You should notice a little bit of difficulty here when we're trying to figure out the other one, x equals y squared, with the x value of -4 and -1. We're actually going to get no real solution for the first two, because any number squared is not going to give you a negative number. And then when we plug in 0, we get 0, and then we get plus or minus 1 and plus or minus 2. So then the next question is, when we're talking about those, what kinds of shapes are those? In both of these cases, they are both parabolas, just how will they look differently? So first off, they are both parabolas. The first one has a vertex of 0, 0, but it will open up. And the second one has a vertex still of 0, 0, but it will open up to the right. So in the past, you've probably done a lot of work with examples like number 1. Looking at an example like number 2, plot the points from that table, and if you recall, we had 0, 0. At 1, it was positive and negative 1. And at 4, it was positive and negative 2. So if you recall talking about functions, does this graph represent a function? And we should be able to say no, because it doesn't pass the vertical line test. So we could look at any one of these spots and say, no, it doesn't pass because of the vertical line test. So based on what we talked about here, when the equation is x equals y squared instead of y equals x squared, the graph is going to open up to the, just like we have above here, the right. The only thing that's different for this next equation, based on the information above, the graph of x equals negative y squared. So the only thing that's different there is having that negative. That would make our graph open up to the left. So then looking at these 4 equations here, which one of them did not open up here, so I will write that one in. Looking at those 4 equations, take a quick second here and decide if they're going to open up, left, right, or down. So if you first recall, we're used to the ones that are y equals something x squared. So you're probably more used to something like number 4, which is an example that will open up. Number 2 is very similar to number 4, except it's got a negative in front of the x, which means it's going to open up down. 1 and 3 are the examples where it's x equals and then some y value squared. So the first one being negative is going to open up to the left. And then for number 3, we're going to open up to the right. So the general form for the equation of a parabola in vertex form is going to be y equals some a value times x minus h squared plus k. Very similar to how we've done some things in the past here, where the vertex, we've done it with some other circles and ellipses, but we're h and k. But in this case, the vertex will be hk. And we've seen it in different forms. We're going to focus on having x minus h squared times some number and then equals y minus k, or just flip-flopping it where the x's and the y's are flipped. This is going to help us when we solve for this number here. It's going to help us find some key parts of our parabola. So you're going to want to get our equations in this form. And we're going to set this number that we get out in front equal to 4p. And then when we solve for p, we can plug it in and find the focus and the directrix on our graph. So what does that look like? So in this first practice one, the vertex we can find first. So opposite of the positive 2, we're going to have negative 2. Opposite of the negative 3, we're going to have the 3. We need to remember to focus on looking at for the x and the y. There, so we have negative 2 comma 3 for our vertex. We're going to need our p-value. So we're going to set 4p equal to negative 20, which means our p-value is negative 5. So now remember to look at this. So our p-value, we also have a y squared one. So because our p is negative 5, we're going to need to go negative 5 for our focus here. So our focus is going to be negative 7, 3. 1, 2, 3, 4, 5. And then our directrix will be in the other direction, and it will be the line x equals 3. So 5 units the other direction. 2, 3, 4, 5. And again, we should be looking at our graph opening up to the left or to the right because it's y squared, and then we have that negative, which means our graph is going to open up to the left. Our axis of symmetry is going to be y equals 3. And then we get some other points by using the focal chord. The focal chord is 2p units. So because our p is negative 5, 2 times negative 5 means that it's negative 10 or 10 units. And we're going to go 10 units off of the focal point. So 10 units above or below that point. And then we'll use those 2 points with our focus, our vertex, to graph our parabola.